Okay, so let's analyze our problem. We have a stairs of 5, and we are placed randomly to these stairs. So we might start from here, or we can start from here, meaning that we have 1 over 5 probability on starting from a specific stair. Okay, now we are gonna perform these operations. So our goal is to reach this stair. This is on the bottom. Okay, so let me show it like this. We want to reach to this stair. And in order to reach that stair, we are going to perform these operations. If we are at this stair, let's say this is a human, because we are already at that stair, we do nothing. So if we start from this bottom stair, we count it as a success, we finished it. If we are at one of these 3 stairs, then we are either going to go up or go down with a probability of 1 over 2. So we are going to 1 over 2 go up, with a probability of 1 over 2 go down. For this stair too, we can go up or go down. 1 over 2, 1 over 2. And for this one too, 1 over 2, 1 over 2. And if you're at the stair that is at the top, then we only are going to perform one single operation, and that is to go down like this. So this is a probability of 1. Now, what we are interested is to find the average amount to reach this step for every single case. So if we are going to calculate, if we start from this stair, what is the average amount of steps that are going to be taken in order to reach this stair? And we are going to find that value for all of our stairs. And then we can work on with this probability. We can calculate the expected value of, or in other words, average value of reaching this stair, given that we start randomly. So we are going to calculate the probability of, not the probability, the average amount of steps that needs to be taken to reach this bottom step for all of these stairs. And now we are going to calculate, if we are placed randomly, then what is the expected value, what is the average amount of steps that need to be taken in order to reach this step. So let's use this syntax then. Let's have mu, or let's represent it with k. I changed my mind. Yeah, k. And we also are gonna say ki. So what does this mean? This means that number of average, actually this is average number of steps that is need to be taken to reach 1. So by 1 I name this stair. So we are gonna also name the stairs. Let's say this is 1, this is 2, this is 3, this is 4, this is 5. Yep, okay. Now, maybe some of you might have realized this is actually a Markov chain. And let's represent this Markov chain. So we have, let's represent it with this color. Yeah, like this. 1, 2, 3, 4, and 5. We have 5 stairs. And then 1, 2, 3, 4, 5. This is the bottom stair, and this is the stair that is on the top. Let's represent our probabilities. Actually, I made a mistake in here. This is gonna be like that, not like this. Okay, then we can say this has an occurrence of 1 over 2, 1, 1 over 2, 1 over 2, 1 over 2, 2, 1 over 2, 1. Okay, so these are basically the probabilities. Now, coming back to this syntax, k of I. Now, k of 1. So if we set I equals to 1, so I equals to 1, we have k of 1, right? And k of I is equal to some average amount of steps that is need to be taken to reach this bottom stair. So then we know that because we are at this bottom stair, then the average amount of steps that is need to be taken to reach this bottom stair is 0 because we are already at that stair. So what is then k2? Now for k2, we are either going to go up or go down. So when we move a step, right, we put 1 in here plus. Why did I put 1? Because we move a step from 2 to 3 or 2 to 1. That's why I add 1 to our expression plus. With the probability of 1 over 2, we are gonna move here, right? We are gonna be at the first index, first position. So in order to reach this first step from the first position is k of 1 plus. With a probability of 1 over 2, we are going to be at this place, and we have a probability of 1 over 2 on reaching that place. And from here, in order to reach this first stair, we need to take k of 3 amount of steps. So basically, this is k2. We take one step from either up or down. For a probability of 1 over 2, we are going to land on this first stair, and to reach first stair from the first stair, we need to use this syntax k1, and with a probability of 1 over 2, we are going to land on this third stair, and to reach third stair from the first stair is this average number of steps is need taken. And then we are going to do this for all of our values. So we are going to say okay, we have written all of our values. And we know that k1 is 0, so we can just disregard this. And our equations are these now. We have 4 different equations in here. We have 4 different variables. So we can solve this system of equations and get just one unique answer in real numbers. Or we can just head into Google. Oops. And I entered my equations, as you can see. And it generates the solutions for us. So A is 16, 15, 12, 7. So let's say, so when you calculate the answers for these solutions, K2 is going to be 7, K3 is going to be 12, I guess, right? Yeah. K4 is going to be 15, and oops, K5 is going to be 16. So what does that mean? Assuming, let's say you start from the third step. In average, you are gonna reach the first step in average of, if you take like 12 steps, and then we expect you to arrive to this first step. And of course there will be cases where you are gonna go, let's say we start from third stair, you go up, down, down, up, down, down. Yeah, there are gonna be cases like that, but the probability of that case occurring is so low that they just doesn't affect our answer that much. And we also know that let's also add k1 to our equation. So k1 equals to 0. Now we know that if we start from a random index, we know that after how many amount of steps we can on average reach this first index. Now let's let's use this number. So assuming you are placed randomly, okay, what is the amount of steps that you need to take in order to reach this first step? So now we are placed randomly, right? And we have an probability of 1 over 5 of starting from the first step. If we start from the first step, we take 0 amount of steps because we're already at the first step. If we start from the second step with a probability of 1 over 5, then we on average should take 7 different steps, and third, fourth, fifth. Now what we can do is that we can say, let me write it in a notation, or yeah, let me write it in a notation. We can say from I equals to 1 to 5, 1 over 5 multiplied by k of I. Let me write it in, yeah. So this will give us, this expression is going to give us the answer that we are looking for. If we place randomly with a probability of 1 over 5 to any of these stairs, and if we multiply that probability with the amount that is need to taken, then, and if you sum those values up, then you get a value that will be the expected amount of steps that you are going to take given that you are placed randomly. And this is equals to 1 over 5 parentheses. I didn't calculate this. Let's see. 1, 2, 3, 41, 43, I guess 50, right? Which is equals to, yep, 10. What does that mean? So let's say somebody comes up to you and says, I'm going to place you randomly. Then you expect to arrive to the first step after 10 steps taken. However, if the starting step is given, let's say you start from the second step, then the amount of steps on average that need to be taken is different than what we found here, because in here we assume that we don't know which step we start from, but in here we know that which step we start from. So this is a Markov chain problem that I wanted to share with you. I mean, we didn't use any matrices or some sort kind of like that. I didn't want to just calculate those stuff because I wasn't actually interested in that in the first place. And this is a problem that you can show off to your friend, your family. I don't know, it's good to know. Like, I like these fun facts, they're good to know. And that's it for this video.